All right, let's get right into it. We're going to talk about something really strange, a gas that is at the same time a feared carcinogen and a prescribed medical treatment. It's a substance some people pay a fortune to get out of their homes, while others are paying to go sit in a cave and breathe it in. This, right here, is the wild paradox of radon gas. So on one side, you've got the U.S. Environmental Protection Agency, the EPA, saying loud and clear that radon is the #2 cause of lung cancer, right behind smoking. But then on the other side, you have entire medical systems in places like Austria and Germany where doctors literally write prescriptions for radon therapy and insurance companies actually pay for it. So how can both of these things possibly be true? To really understand this, we've got to go back in time. We're heading back to the early 20th century. This was a time when radioactivity wasn't something to be feared. No, it was celebrated. It was seen as this miracle of modern science. So right after radium was discovered, the public just went nuts for it. It was this magical, life-giving force. Now, radium itself was insanely expensive, so its decay product, radon gas, was sold as the affordable option, the poor man's radium. And that kicked off this huge boom in radioactive consumer products. But the whole craze came to a screeching halt in 1932 with the absolutely horrifying death of a wealthy socialite named Eben Byers. He had drunk over 1,000 bottles of a popular radium-laced tonic. And you just have to see some of these products to believe them. I mean, you had the radium ore revigorator, which was basically a water jug lined with radioactive ore that promised to cure everything from arthritis to, well, flatulence. Then there was Radithor. That's the stuff that killed Eben Byers, marketed, and I'm not kidding, as a cure for the living dead. And the radioindoctrinator. Well, let's just say it was a device that men were supposed to wear in their underwear to vitalize certain glands. The risks, as we now know, were absolutely catastrophic. So, while that consumer fad died out, the idea of radon therapy, it didn't really disappear. It just went underground, literally. And today, it exists in two completely different worlds. First, you have the United States, and specifically this little cluster of what they call health mines in Montana. Here, the experience is, well, rustic. We're talking about people traveling to these cold, dark tunnels, often as a total last resort when nothing else has helped their chronic pain. It's totally unregulated, it's not medicalized, and it's way, way outside the mainstream healthcare system. And that brings us to the complete opposite end of the spectrum in Europe. In places like Bad Gastein, Austria, patients get on a specialized train that takes them deep inside a mountain into these warm, humid galleries. A doctor has to prescribe it, they monitor your health the whole time, and insurance often foots the bill. It is a fully integrated, accepted part of the biomedical system. Okay, let's just look at the numbers for a second, because this is where it gets really mind-boggling. The average American home has a radon level of about 1.3 picocuries per liter. That's just the unit they use. The EPA says you need to fix your house if it hits 4. Now, a Montana health mine, it can have radon levels as high as 1,600. That is 400 times the EPA's action level. And this massive, massive difference is really at the heart of the whole scientific debate. So, how do we make sense of this? How is this even possible? Well, it all comes down to two completely opposing scientific models for how radiation actually affects the human body. In one corner, you've got the linear no-threshold model, or LNT for short. This is the official playbook for all U.S. radiation safety. It's a really cautious model. It basically assumes that any dose of radiation, no matter how tiny, increases your risk of cancer. There is no such thing as a safe level. And in the other corner, you have the Hormesis Hypothesis. This is the whole theory behind radon therapy. It argues that, yeah, high doses of radiation are obviously bad, but it says that very low doses can actually be beneficial. The idea is that a small stressor can kind of kickstart the body's own defense and repair systems, making them stronger. So let's just put it plainly, because this is the core of the whole thing. The LNT model says any dose is a risk. Hormesis says a small dose might be a benefit. They cannot both be right. Now, the people who support Hormesis, they think it works by basically waking up your cell's own internal repair crew. They believe that this low dose of radiation can stimulate enzymes that fix DNA damage, boost antioxidants that fight off inflammation, and even sort of retune the immune system to calm it down. So, we have the theories. Now let's look at the evidence. What does the actual data say when you put the risk of cancer up against the promise of relief? Okay, the evidence for risk is strong. It comes from decades of studying uranium miners, and those studies show a really clear direct link. The more radon miners were exposed to over many years, the higher their risk of lung cancer. This data is pretty much the foundation for that LNT model. But then,
the evidence for relief, you can't just dismiss it. There have been randomized, controlled trials in Europe that show radon therapy gives people significantly better long-term pain reduction for things like arthritis than a placebo. And what's really interesting is the relief isn't immediate. It kicks in months later, which suggests it might actually be changing the underlying biology of the inflammation.
To really understand why anyone would even think about taking this risk, you have to hear about the level of suffering we're talking about. The manager of one of the oldest mines in Montana said this: "It just speaks to the absolute desperation of people who are living with this relentless, debilitating pain that modern medicine just hasn't been able to fix." And yet, you cannot ignore this number. The EPA estimates that 21,000 Americans die from lung cancer caused by radon in their own homes every single year. It's a risk that public health officials take incredibly seriously. So we end up right back where we started, with this seemingly impossible choice. On one side, you have a statistical, long-term risk of cancer, backed up by decades of public health data. And on the other, you have the potential for life-changing relief from a daily agony that nothing else has been able to touch. There's just no easy answer. And this whole dilemma, it really gets at a fundamental debate in science itself. How do we balance a risk to the population against a potential reward for an individual, especially when that individual is desperate? It really forces us to confront the limits of our own scientific models when they come face-to-face with human suffering. And it leaves us with the one question that truly matters to the person in pain: is this a risk worth taking?